Alright guys, welcome to the next lesson of our matrix unit. And this chapter we're going to go through chapter 5e, which is focusing on matrix multiplication. So multiplying two matrices together. Now, just really quickly, last lesson we looked into scalar multiplication. So with this, the concept behind this is all the numbers inside the matrix has to be multiplied with the number outside of that matrix. Okay, but the slight difference here with chapter 5e is that now you're multiplying two matrices together. So one matrix with another matrix. Okay, that's the difference. So let's get started with this and hopefully you'll understand it. So matrix multiplication, like I said, is the multiplication of a matrix by another matrix. And the way you multiply it, as it states here, is the first row of a matrix. Okay, so the row of the first matrix must be multiplied with the column of the next matrix. So the row of that first matrix you have must be multiplied with the column, okay, of the second matrix, and that process gets repeated. Okay, so because each row in that first matrix must be multiplied with each column of the next matrix. Okay, let's use this as an example, see how it works. So in this first part here, you've got 7 by this matrix, sorry, n times this matrix p. So the idea is we have to multiply the whole row of the matrix with the column of this matrix. So the first part is 7 by 20, so that's the first one. And then the second part is 4 by 30. Okay, that's the second part here. Okay, this one here you've got, and it's the same process for the bottom row here. 5 by the 20, which we'll see here. 6 by the 30, which we'll see here. Okay, and we can see, once that's all evaluated, okay, so 7 by 20 plus 4 by 30, and then the bottom one is 5 by 20 and 6 by 30. Get this. Okay, you add them all up and we get 260 and 280. Now, let me actually explain this in another way because this is probably not the greatest example. Okay, so let's say you have, I'll make up my own matrix here. Let's go with a 2 by 2, so 1, 4, 5, 6. And we'll multiply it with a 2 by 3. Okay, 7, 1, 2, 1, 0, 4. Let's just go with that, okay? So the principle behind multiplying two matrices together, okay, remember? Okay, is as we move across the first row of matrix N, we will move down matrix P. So I'll repeat that again in other ways. It's basically the whole row of that first matrix multiplied by the columns of the second matrix. So it's always row by column. So you're going to go row times the column. Row times column each time. All right. So let's evaluate it. Okay, row times column. So I'm going to use colors for this so we all see what's happening. First row with the first column. So 1 times the 7. All right. So 1 times 7 plus 4 times the 1. 4 times 1. Okay, that's the first part. So that's that row done for this. That's that column done for this row. Now let's go to the next one. Let's just make this a bit bigger, guys. Let's go to the next set of numbers. Same principle, yeah. Row times, this time we've done the first column. Now we go to the second column. So 1 times that 1. So 1 times 1 plus the next number in that row is 4 times the 0. 4 times 0. That's always row by column, row by column. So the next one is going to be 1 by 4 with this 2, and 4. Okay, so it's going to be 1 by 2. Let's use another color, sorry. 1 times 2 plus 4 times that 4. Okay. So that's the first row of that matrix done. Okay, the next part. Let's go with this column. So now we do the bottom row with the other columns again. So it's always row by column, row by column. So this is 5 and 6 with this 7 and 1. Let's start with that. So that's going to be on the bottom row here now. So 5 by 7 is, so 5 by 7, let's not evaluate it yet, plus 6 by 1. Okay, which is the bottom. So this one and that one. Next one is, again, row with column. Okay, row by column. So 5 by 1, 5 times 1, plus 6 times 0. Okay, easy. And the last one, again, row. So this row times this column. Okay, that's what I'm doing each time. 5 by 2 is, yep, oops. Let's change color. 5 by 2. Okay, and then 6 by 4. So remember, just remember that process, guys. It's row times column, okay? All right, so working that out. Now we evaluate the whole thing. Equals. So once you evaluate, let's just do it all. So 1 by 7 is 7, plus 4 by 1, which is 4. Let's just do it by row. So 1 by 1 is 1. Oops. 1 times 1 is 1, plus 4 times 0 is 0. And then 1 times 2 is 2, plus 4 by 4 is 16. Okay, next to the second row now. 5 by 7 is 35, plus 6 times 1 is 6, sorry. 5 by 1 is 5, plus 6 times 0 is 0. 5 by 2 is 10, plus 6 by 4 is 24. Okay, and then we add them all up to finish things off. It does seem a bit tedious, but once you get used to it, it's not that bad. Okay, so 7 plus 4 is 11. 35 and 6 make 41. And then you've got 1 and 0 is 1, 5 and 0 is 5. And then the last number, 2 and 6 make 18. 10 and 24 make 34. And there is your matrix. Okay, there's your matrix. Okay, now interesting thing with this that you got to look out for. Okay, there's some rules when it comes to actually multiplying the matrix. So apart from understanding that, again, it's row times column, row times column, row times column. Okay, some interesting things to note here. Okay, is that the order of your matrix is going to be important. Okay, the order of the matrix is important. I should probably write that here. So when multiplying, okay, order matters. And remember, if you forgot what order means, the order is just referring to the number of rows and columns in the matrix. So what's the order? For example, let's say we have this matrix, 1, 2, 3, 4, 5, 6. Okay, how many rows and how many columns? So what's the order of this? How many rows, how many columns? There's two rows and there are 3 columns. So the order is 2 by 3 with this matrix. Okay. So when multiplying matrices, okay, the order of the matrix actually matters. Okay. Now the reason why I say that is, let's say you have a matrix like this. Again, we'll go back to this. This 2 by 2, so this order is 2 by 2, and this order is 2 by 3. Now the reason why I say order matters is that when you lay out your order like this of both matrices, the middle numbers have to be the same. Okay, you cannot multiply a matrix if the middle numbers are not the same. And let me make an example of that. Let's say you have let's flip this around actually. Okay, let's say you have a 3 by 2 matrix, so 1, 2, 3, 2 by 3 matrix, sorry, 4, 5, 6, and then you multiply that with, let's say, just a 2 by 2. Okay, so 1, 2, 3, 4. Okay, so there's my matrix. The order, so let's write the order down for each one. This is a 2 by 3, and this is a 2 by 2. Now remember the principle for multiplying a matrix. It's always row by column. Okay, but if we try to multiply this, okay, you've got 1 times the 1, the 2 by the 3, but then what do you multiply the 3 with? Okay, there's not enough rows in this matrix to multiply it. Hence why the same number of, so when you multiply two matrices together, order matters, because when you lay them out like this, the middle numbers must be the same. Okay, so the number of columns in the first matrix must be equal to the number of rows in the first matrix. So just remember that. Keep that in mind, please. When you multiply two matrices together, order matters, where the middle numbers have to be the same. Okay, they have to be the same, otherwise you can't do it. It's going to be impossible to do because there's not enough rows to multiply the columns here. Okay, so keep that in mind, please. That's a very important rule when it comes to multiplying two matrices together. Another thing to note that's important when multiplying matrices is that the outside numbers, so these two, okay, actually tells you the order of your answer. So this is telling me that the order of my answer is going to be a 2 by 3 matrix. So the order for the final answer is a 2 by 3, and that's definitely true. There's 2 rows and 3 columns, right? This is a 2 by 3 matrix. 2 rows, 3 columns. All right, so the order is very important when it comes to multiplying matrices. I'll recap that again. When you multiply two matrices together and you lay out the order like this, the middle numbers must be the same. What I'm saying is the number of columns in the first matrix must equal the number of columns, the number of rows in the first matrix. Because if you don't have enough of each, this is what happens. Remember, the principle is row by column. Here you have 3 numbers to multiply, and here you only have 2, so you don't have enough numbers to actually multiply them together. It's because the order is not correct here. Okay, you can't multiply them together. The middle numbers must be the same. And the other thing, is to note is that the outside numbers of the order of the matrices, so when you lay them out like this, first matrix, second matrix, the outside numbers actually give you the answer or the order of your answer. Okay, let's try another matrix to really help you guys understand this. I'll make another one here. Let's go. Okay, let's go with let's go with something easy. So do a 2 by 3. I'll do a 3 by 2 this time. All right, let's spice it up a bit. 1, 2, 0, 1, 4, 2. So that's a 3 by 2. So that means if this is a 3 by 2, keep that in mind, the rows, number of rows in this matrix has to be a 2 by something matrix, okay? So just keep that in mind already. Remember, the middle numbers must be the same. So that means this has to have 2 rows. Let's go with 2 by 4. So this is going to have 4 columns. So let's go 1, 2, 5, 3, 4, 0, 0, 1. Okay, so just looking at the order already, can I multiply these? Yes, because the middle numbers are the same. Okay, and if you think about it, the outside numbers will tell you the answer of your the order of your answer. Okay, so that means the order is going to be a 3 by 4 matrix. So you can already tell if your answer is not a 3 by 4, then you've done something wrong. So let's evaluate this. Okay, I'm going to make this nice and big because we'll probably need a bit more space. All right, let's use color with this. So remember, the principle is row by column. Okay, row by column. So 1 times 1 is obviously 1, but I'll put that in. 2 times plus 2 times 4. Okay, that's the first part. Easy. Remember, yeah, the answer of this matrix is going to be a 3 by 4. Okay, so there's already my first column. I need to have 4 columns in this because it says the answer has to be a 3 by 4 with 4 columns. I might extend this a bit. Okay, we're all the way here. Next one is, okay, so next one is, remember again, it's just row by column, yeah? Row times the column. So now I'm going to the next row. Sorry, same row, but now it's the next column, which is this column, the second column here. So 1 by 2. Sorry, let's use another color. Sorry, guys. 1 by 2 plus 2 by 0. So that's the second column here. Next column. Now I think you guys, once you understand this, it's pretty straightforward. Okay, so now it's going to be, again, this row times this column. Okay, so 1 by 5 plus 2 by 0. Okay, and then the last row, okay, we read this row with this column. Sorry, I said last row, last column. So it's 1 by 3 plus 2 by 1. Okay, so I've just gone 1 and 3, 2 by 1. Okay. Alright, I think you guys understand the process. If you want to watch it, watch me do the rest by hand, go for it. Otherwise, you can skip ahead to the end of me doing all this because it's probably going to be tedious for you. But let me just do it for the people who still want to try and or want to watch me. Just go for it. So 1 and 1. So this is the next. Now, oh, sorry. Already made a mistake. Next, we work with this row. Okay, so now it's this middle row times these columns. Okay, so remember that your matrix, the answer of your matrix, so the order of your matrix should be 3 by 4. Okay, so now I'm up to my second column. That means I need to have 3 rows and 4 columns in my answer. So I've got 0 by 1 plus 1 by 4. Okay, next one is 0 and 2. So 0 by 2 plus 1 by 0. Okay, next one is 0 by 5 plus 1 by 0. Okay, and the last one there, okay, is 0 by 3 plus 1 by 1. Okay. Last and final row now, okay. 4 by 1 plus 2 by 4. Then you've got 4 by 2 plus 2 by 0. And you've got 4 by 5 plus 2 by 0. And the last one, you got 4 by 3 plus 2 by 1. So this and that. Okay, let's evaluate all these. Okay, you don't have to do every single step here. Okay, but let's just evaluate it. 1 by 1 is 1, plus 2 by 4 is 8. 0 by 1 is 0, plus 1 by 4 is 4. 4 by 1 is 4, plus 2 by 4 is 8. Okay, 1 by 2 is 2. 2 by 0 is 0. 0 by 2 is 0, plus 1 by 0 is 0. 4 by 2 is 8, plus 2 by 0 is 0. 1 by 5 is 5, plus 2 by 0 is 0. 0 by 5 is 0. 1 and 0 make 0. 4 by 5 is 20. 2 by 0 is 0. And lucky last, you've got 1 by 3 is 3, plus 2 by 1 is 2. 0 by 3 is 0, plus 1 by 1 is 1. 4 by 3 is 12, plus 2 by 1 is 2. Okay, evaluating this final answer. Alright, so you've got 8 and 1 make 9, 0 and 4 make 4, 4 and 8 make 12. Second column, 2 by 2, or 2 by 0, 0 by 0, 0 plus 0, 8 plus 0 is 0. 5 by plus 0 is 5, 0 plus 0 makes 0, 20 plus 0 make 20, and then the last one, 3 by 2 is 5, or 3 plus 2, sorry, 0 plus 1 is 1, 12 plus 2 is 14. And there is my answer, okay, for that matrix. Okay, I hope that's making sense so far. Okay, I'll skip that. I've just spoken about it. Okay, that's basically it. Let's see. Yep, I'll keep it at that. Next is just really quickly on the CAS. How do we do this? Okay, so pretty straightforward. You guys know how to make a matrix, all right? Again, if you need to use the app, go for it on the online version. But I won't go over how to use that. I will go over how to use your CAS to do this. Okay, so we've already gone home, make a new document. Oops, sorry. Home button. Nope. So new document. Add a calculator. Okay. Then we go to this button here. And we can use any matrix you want, but in this case, I'll go with we'll make a 2 by 2 matrix for now. So we'll just put whatever number we want. 1, 2, 3, 5. I can call this matrix A. So to name that, press Control var, make it matrix A. You know how to do this, okay? And now let's make another matrix. We'll make a 2 by 4 this time, okay? So this is a number of rows is 2, number of columns, oops, and number of columns, make that 4. Okay, so we'll just put some random numbers in. Okay, name it. So press Control var, call this matrix B. Okay, and then to multiply two matrices together, we're going to go, in this scenario, we're going to go this matrix, which is I'll just put it like this for now. This matrix multiplied by this matrix. Remember that when you multiply two matrices together, the order matters, yeah? So this is a 2 by 2, and this is a 2 by 4. So the middle numbers of this matrix, okay, it must be the same. Okay, that's a 2 by 2, that's a 2 by 4. And because you know that the outside numbers are 2 and the outside numbers are 4, the product, okay, or when you multiply these together, the order of them is going to be a 2 by 4, which is correct. So 2 rows, 4 columns. And again, that's how we do it by hand like that. But if you did it on your calculator and you named your matrix A and B, you can literally just go A, let's press it for you guys, times B. Okay, and then that'll give you the order of the answer. Now remember, order matters, yeah? If I actually went B times A with this, would it work? No, it wouldn't. Okay, because if you think about it, let me put this in for you guys. So if you go this matrix multiplied by the A matrix, which is this, remember this order, okay, is now a 2 by 4, so the middle number is 4, and this is a 2 by 2. Okay, the middle numbers don't match anymore, because if you think about it, the numbers of numbers here, so there's 4 columns here, and if you want to multiply that with these numbers here, there's not enough numbers in this row. Okay, there's only 2 numbers here. So the columns of the first matrix must match the number of rows in the second matrix in order to multiply them together. Cool. Alright, so that's it for this video, guys. Go ahead and do chapter 5E and just do those questions. Thank you.